Hello class, welcome to the third part of subtopic 3.8, solution to trigonometric equations over a finite interval. And today I'm gonna go over three examples, guys. This is the first example. I believe that I already worked this one out with group 420 if I'm not mistaken. But anyways, since I did not teach you this concept, let's face it as though it's the first time we see this problem. So the first thing I'm going to explain to you today, guys, is the concept of losing solutions to an equation. Losing solutions. What does that mean? Okay, let's face this problem so I can tell you what this concept is about. So as you can see, we have the same equation, sine of 2 theta equals tangent of theta. Can you see? It's in both columns. It's going to be the same equation. And we want to solve it over the same interval, where theta is in the interval from 0 to pi, including 0, excluding pi. I forgot in here the symbol of belonging. Theta belongs in the interval from 0 to pi. Okay, and I'm going to solve it, guys. I'm going to speak out loud. I'm going to tell you at each point what I'm doing. And I'm gonna solve it by using two slightly different methods. We're gonna observe the conclusions of each of these different methods, and we're gonna realize that something interesting is happening when I do this. Okay, so let's get started. So in here, what I'm gonna do first is I'm gonna transform sine of 2 theta by using one of the identities in the booklet. This one, sine of 2 theta equals 2 sine of theta cosine of theta. I'm going to use this identity. So here we go. And for tangent of theta, I'm going to write sine of theta cosine of theta. Okay, that's how I first start. Remember, there is no way you can know that this is the thing that you have to do first. There is no way to do that. You just have to try things until something eventually provides you a good route to the solution. Okay, next, what can I do? I can multiply both sides by cosine of theta. So let's do it. I'm gonna get this. This is what you get after you multiply both sides by cosine of theta. Perfect. Now, let's somebody may think, okay, at this point, since we have sine of theta in both sides acting as a factor, we can simplify this whole equation by dividing both sides of this equation by sine of theta. And I'm going to write a little star over here because I want to come back to this point in a moment. And I'm going to perform that step. I'm going to divide both sides of this equation by sine of theta. So after we do that, we are going to get this. I divided both sides over sine of theta. Okay, and then from here onwards, it seems like it's a very simple equation. I divide over 2 both sides. And then since I have the square of the cosine of theta, I can take the square root on both sides. Remember to add the plus and minus. Then we have cosine of theta being equal to plus minus the square root of 2 over 2. After you simplify this square root, you should get this. Okay, and then what this tells me is that I have two equations written as a single one. Cosine of theta equals the positive of this number, and cosine of theta equals the negative of this number. So I need to separate both equations. This is one of them. The other is this. Okay, and then I independently solve each one, this one and this one independently. So cosine of theta equals the square root of 2 over 2. Once again, I go back to my main image that we have been using these days, and I look at the x coordinates and I look for the square root of 2 over 2, which is this one for pi over 4 radians, and also here for 7 pi over 4 radians. So remember, pi over 4 and 7 pi over 4. So let's do it. Well, let me see if it fits in here. So I have in here that theta must be pi over 4, or theta must be 7 pi over 4. And these are the two solutions that I get for this equation. I get pi over 4 or 7 pi over 4. Now I need to solve this one. For what angle theta do I get that the cosine of theta is this number minus the square root of 2 over 2? Well, that's gonna be, it's right here for 3 pi over 4, and it's right here for 5 pi over 4 radians. So 3 pi over 4 and 5 pi over 4. So let's go back here. 3 pi over 4 or 5 pi over 4. Okay, so these are all the possible solutions that I get for this equation. Okay, now we just have to look at the interval. My interval goes from 0 to pi, excluding pi, and I just start to either accepting or rejecting each of these possible solutions. Pi over 4 is in this interval, so this one does work. 7 pi over 4 is not within this interval, so I'm going to reject it. 3 pi over 4, is it in here? Yes. And 5 pi over 4 radians is not inside this interval. So that's it. Okay, so this is the conclusion for this specific equation. Following this algebraic method, I get as a conclusion that I get two solutions, pi over 4 and 3 pi over 4 radians. Okay, and apparently there is nothing wrong with all of this process, right? Apparently there is nothing wrong. We're gonna come back to this in a moment. Now let me face the same equation, guys, the same equation exactly, by following a slightly different method. I'm gonna start in the same way. I'm gonna replace this for 2 sine of theta cosine of theta equals sine of theta over cosine of theta, and then I'm gonna multiply both sides by cosine of theta. There you go. And now at this point, which in the other method we the next step was dividing both sides over sine of theta. Can you remember? Going from this second step to the third step, we divided over sine of theta. Now in this other method, guys, I'm not going to do that. I'm not gonna divide both sides over sine of theta, and I'm gonna mark also this step. So what am I gonna do instead? I'm gonna subtract sine of theta from both sides so that I get the following. Like that. Okay. And then what I can see that I can do is this. Since I have these two terms, this one and this one, they both contain sine of theta as a factor, and therefore I can use it for a factorization. Sine of theta that multiplies 2 cosine squared of theta minus 1 equals 0. Can you see? This times this will give me this term, right? And this times this will give me this term. Okay, fine. Let's move on. Now, what are we having here? We have the multiplication of this number and this number being equal to 0. And remember, whenever you have a times b equals 0, that means that a is 0 or b should be 0. So let's employ that fact once again. So what can I deduce? I can deduce that either sine of theta must be 0 or that 2 cosine squared of theta minus 1 should be equal to 0. And once again, I solve this and this equation independently in order to find all the possible solutions. So sine of theta equals 0. That's going to occur when theta is 0. And for this other one, I need to continue doing a little bit. We have 2 cosine squared of theta being equal to 1. And then we have cosine squared of theta being equal to 1 over 2. And then we take the square root from both sides. You're going to get this. And finally, for what angle theta do I have that cosine of theta is equal to, well, I need to separate. This means that cosine of theta equals the positive solution, or cosine of theta equals the negative solution. Okay, but if you notice, guys, we have already solved this one. It's in here. Can you see? It's the same equation. So I don't need to do anything else. I'm just going to copy the solutions that I got, which were this and this, for this equation. So I'm going to just write the solutions. Theta is going to be equal to pi over 4, or theta is going to be equal to 7 pi over 4. And for this one, we got that theta should be equal to 3 pi over 4, or that theta should be equal to 5 pi over 4. 5 pi over 4. Once again, I get I look at all my possible solutions that I get in the end, which is this, 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 and this, and I just start accepting them or rejecting them according to the interval that I was given. I was given the interval from 0 to pi, including 0, excluding pi. So does this work? Yes, because it's 0 and 0 is within the interval. And then these ones are in fact the same as these other 4, right? So pi over 4 is accepted, 7 pi over 4 is rejected, 3 pi over 4 is accepted, right? And 5 pi over 4 is rejected. So I'm done. Now let's observe what happened, guys. Can you see what happened? It's very evident. With this other method, guys, we have in fact another solution, this one. Another possible solution to the same equation over the same interval with respect to the other one, right? With this method that I followed, I just got two solutions, pi over 4 and 3 pi over 4. And for the same equation and the same interval, by following a slightly different method, I get the same two answers as before, which are right here, pi over 4 and 3 pi over 4. But I also get this other one. I get an apparently new solution, which is 0. So what's up with that? What's up with this phenomenon? Okay, let me explain to you what happened, guys. What happened is that by following this method in here, we lost a possible solution to this equation, which is the same, okay? And I need you to understand that this and this are exactly the same. The only thing that changed was the method by which I tried to solve them. Why does this method cause you to lose a solution? The problem is right here, going from this step to this step, going from the second step to the third step. The problem, guys, was that we divided over sine of theta, both sides. And you may be thinking, well, what's wrong with that? What's wrong with dividing all of this over sine of theta and all of this over sine of theta. What's wrong with that? What is wrong with that, guys, is the following. Remember that in algebra, we have the following. If you have an equation, let's say a equals b, a very simple equation, you can always divide both sides by the same number as long as it's not 0. Okay, I can divide both sides over 2, and that is perfectly okay. I can divide both sides over 3, that is perfectly okay. The problem is when I try to divide both sides over 0, which is not even possible, right? We cannot do this. I'm sorry, over 0. We cannot divide both sides over 0. That's impossible, and whenever we do that, we're gonna cause trouble along the way. So, are we dividing over 0 in here? Well, you may be doing that without noticing it. What is the problem? What is the problem when we divide both sides of an equation by not a constant but a variable? These guys, this expression sine of theta is not a constant. It's not 3 or -2 or 1 or 0.5. You know what I mean, right? This value, you don't know the value. I mean, this expression, you don't know the value of this. It's just an algebraical expression. It can be many possible numbers. It depends on what value you give to theta. Can you see that? So, by dividing any equation, not just trigonometric equations, don't think that this idea only involves trigonometric equations. This is general. When you divide both sides of an equation by an algebraical expression or a variable expression, this is a variable expression, because you don't know what the value of this is until you assign a value to theta. And when you do that, you may be dividing over 0 without noticing it. And what that is going to cause is that you may lose solutions. It's not always the case, but it's very frequent that when you divide both sides of an equation by a variable expression, you may lose solutions or cause some other types of trouble. In here, I did not do that. Can you see? At this point, when we were at this second step, I refrained from dividing both sides over sine of theta, and I said, no, let's not do that. Let's just bring this term to the other side so that it becomes negative, right? And then I started to do another process, but I never divided both sides of the equation by a variable expression. So with this method, I was kind of like playing safe. You may think of this as playing safe by not dividing ever over a variable expression. And this is, in general, the best method to solve any equation, not just trigonometric equations. I remind you, this is a general idea. So whenever you want to play safe, don't divide both sides of an equation by a variable expression, and you will be more assured that the solutions that you're gonna end up with are gonna be all the solutions possible, and that you won't be losing any solution, like in this case 0, which were lost with this method. You see how it works? So let's play safe, guys. Let's not divide both sides of an equation by a variable expression like sine of theta or any other expression. And that's the way we have to do these problems in order to find all the solutions. In this case, it's fine. I mean, there is really nothing strictly wrong with doing this. The problem is that you lost. You lost one solution. That was the problem. Okay. So I hope that's understood. Let me show you another example. 19. Okay, one more, and then we can do another one live. So let's see. We have 2 sine squared of theta cosine of theta equals sine squared of theta. And we want to solve this equation over the interval where theta is in the interval from 0 to pi, including both numbers. Okay, let's get started. So same thing, guys. It could be very tempting. By observing this equation, we may say, okay, I have sine squared of theta in both sides. I may divide both sides by this, right? By sine squared of theta. But I told you that every time that you try to do that, you may lose solutions. If you do this, you may lose solutions. So let's not do that. Let's refrain from doing that. And instead, let's bring this term to the other side. So let's basically subtract sine squared of theta. Like that. Okay, I just subtracted sine squared of theta. Let's keep on moving. So I have two terms. They have a common factor, which is sine squared of theta. So I may as well factorize it. And sine squared of theta is going to multiply 2 cosine of theta minus 1 equals 0. Okay? And then I have a multiplication of two expressions being equal to 0. That means that either the first expression must be 0 or the second expression must be 0. Okay. Now, sine squared of theta equals 0. Let's take the square root from both sides. So I have sine of theta equals 0, and that happens for theta equals 0. So this is one of my possible solutions. Now let's solve this equation. We have 2 cosine of theta equals 1, and then cosine of theta equals 1/2. And then I go look into my image for what angle is the cosine of such angle equal to 1/2. Let's see. I look at the x coordinates. It's right here for pi over 3. And it's right here for 5 pi over 3. So it's pi over 3 and 5 pi over 3. So theta is either pi over 3 or theta is 5 pi over 3. And I'm done. I have obtained the 3 possible solutions to this equation. Now, all I need to do is look at the interval that I was given. The author of this problem told me, you only need to consider solutions for theta that are within this interval from 0 to pi, including 0, including pi. So does this work? Yes. Does this work? Yes. And does this work? No, because 5 pi over 3 is outside this interval. So the only conclusion is that the solutions to this equation over this interval are theta equals 0 and theta equals pi over 3. We discard this solution, and remember that we did not attempt at first. We never tried to divide both sides over sine squared of theta, because in that way we may lose solutions. So you want to keep it safe. Don't try to divide over variable expressions. Let me show you very quickly another example of how this works. Consider this equation, guys. X squared plus 2x equals 0. Okay, so let's solve it. It's a very simple equation to solve. It's a quadratic equation that doesn't have the constant term, so it's very simple to solve. Let me factorize an x, so we get this, right? And then that means that since I have a multiplication being equal to 0, that means that x equals 0. That's one solution. Or that means that x plus 2 equals 0, which means that x equals minus 2. And that's another solution. Okay, now in here I'm not restricting my equation to any interval, so it's completely open. So 0 is a solution to this equation, and -2 is another solution to this equation. Perfect. That is perfect. Now look at this other way in which I'm gonna try to solve the equation. Same equation, can you see? And I'm gonna do this. Look, x squared equals -2x. Okay, and then I'm gonna do this. I'm gonna divide both sides over x. Both sides, I'm gonna divide them over x. I'm gonna do that in blue. I'm gonna divide this over x and this over x. What's going to happen? X squared over x is x, minus 2x over x is -2, and apparently I'm done because I already arrived at x equals some value. So this is it. I'm done. And in fact, this is a solution, right? Just like before. X equals -2 is a perfectly good solution to this equation. But what is the problem, guys? The problem is that we lost this other solution, x equals 0, and the reason was that we divided both sides of an equation by not a constant but a variable expression. When I divide both sides over x, I really don't know whether I'm dividing over 0. That's a possibility, and that's what causes this problem of losing this solution. You see? So always, as much as possible, try to refrain or try to do this step of dividing any equation by a variable expression. You can always divide over a constant, no problem, but not over a variable expression because that may cause problems. Okay, I'm gonna stop it right there. Thank you, guys.